In this video, I'll find the electric fields and electric forces that are associated with point charges. So in this first example, imagine nothing exists in the universe except for this one charge. What is the force on the charge? We've done that before. We came up with 0. Now can we see mathematically why it's 0? Well, let's see. The force on the object has to be the charge of the object, so whatever charge this is, this plus charge, times the electric field, and this is the electric field external to the charge. So imagine this is a test charge. So if we removed that, what would the electric field be at this location? There's nothing else in the universe. There's no field. So this E is 0, so the force on it also has to be 0. Now let's try one with two charges. So this time we have a plus 3 nanocoulomb charge here and a minus 2 nanocoulomb charge here with a distance between them of 0.04 meters. What is the force on the charge on the left? And then we're also going to look for what is the force on the charge on the right. I've redrawn the problem here and I've given them labels. This is thing 1 and this is thing 2. So then I can say that Q1, the charge of thing 1, is plus 3 nanocoulombs, Q2 minus 2 nanocoulombs. R is the distance from the charge to the point we're interested in. I know in this case we want to know what the force is on one object and the force on the other object. So if I'm looking at this object, then the distance from this to the charge is this, 0.04 meters. If I'm considering this one, then the distance from this to the charge is 0.04 meters. All right, so we're looking at the force. This is the force of thing 2 on thing 1. And that force is QE. So in this case, this is the E created by thing 2 times the charge of thing 1. Now, what is this? To look at the field only of this charge, we have to remove this one. So think of this one as a test charge. So the electric field lines of this one go in from all directions. That means at this point, the direction is to the right. So E is to the right at this point. That's called E2. So now we know the direction of E2. So F of 2,1, here the electric field points to the right. This charge is positive, and so since the charge is positive, we know the force is in the direction of the field. So whatever this force is, I know the direction is to the right. So now we just need to find the magnitude of this. F21 is the magnitude of K Q2 Q1 over R squared. So this is 8.99 times 10 to the 9th Newton meters squared per coulomb squared times Q2. Negative 2 times 10 to the minus 9. Nano is times 10 to the minus 9 coulombs times plus 3 times 10 to the minus 9 coulombs over R squared, 0.04 meters squared. Now my units, I've got meter squared on the bottom, meter squared on the top, those go away. Coulomb squared on the bottom, coulombs times coulombs on the top, so those go away, we'll be left with newtons, which is good because we're looking for a force. And this is 3.37 times 10 to the minus 5 newtons. So 3.37 times 10 to the minus 5 newtons to the right. So that is the force of thing 2 on thing 1. How about force of, oh, I should have a vector here. Force of thing 1 on thing 2. These two have to be equal and opposite. So I don't have to do any math. If I did do the math, all that would happen is I would switch this Q1 and Q2 and the direction would be reversed. And the direction's reversed because the electric field, if this goes away, and this is your test charge, field lines come out of it. So the electric field here is to the right, caused by this one. And this is a negative charge, so the force on it is opposite. So to the left. To the left. And it has to be the same size.